So welcome back. In this video you'll learn a bit more about the solar system. So as you can see in this picture, the sun is here given with this yellow dot, and there is a circular orbit around it, and there is also an elliptical orbit around it. So an ellipse is like a compressed or elongated circle, and the earth is this point and the moon is revolving around the earth, always staying with the earth while the earth moves around the sun. So the moon's orbit around the sun is a bit more complicated. We call it epicycles. Okay. So just like the earth has moons, different planets have different number of moons. Saturn has the maximum number of moons. Jupiter also has a lot of moons. So some general facts about the planets in our solar system. The further a planet is from the sun, the slower it travels and the more time it takes to complete an orbit. So let us see how we can make sense out of that statement. So it's like this. The gravitational pull of the sun gets weaker with distance. So the centripetal force exerted by the sun, which is supplied by the gravitational force, gets weaker as the planet goes further away from the sun. Now we know the centripetal force is mv square by r, and as you go further from the sun, r also becomes bigger, and since the force also becomes weaker, so force becomes weaker and r becomes bigger. So you have, let me write it here. Okay, pencil tool is here. Okay, so you have centripetal force equal to mv square upon r. So for a planet which is very far away and the centripetal force is given by gravitational force, so gravitational force will get weaker, it will go down, centripetal force will also go down. So this whole term has to go down. But the radius is getting bigger for planets which are further away. So this also makes the whole term go down. So if r is getting bigger and m is fixed value, the centripetal force is already decreasing. So what can we conclude about the speed, orbital speed? So orbital speed will also actually the rate at which the gravitational force decreases with increasing distance from the sun is much faster than the rate at which centripetal force will decrease, only due to the increase in distance r. So to compensate for the same rate of decrease in force, we need the velocity also to decrease. So that is one way of understanding why the speed will decrease for planets which are further away from the sun. Another way to understand is, if the planet is getting closer to the sun, its gravitational potential is getting reduced because it is traveling towards the direction of gravitational force of attraction of the sun, and that is converted into a gain in kinetic energy of the planet. So the planets which revolve closer to the sun have lesser gravitational potential energy but more kinetic energy, giving them more speed while they orbit around the sun. So Mercury will orbit at a very high speed and Pluto will orbit at a very low speed. Then the temperature also. So with with the increasing distance from the sun, with increasing distance from the sun, the temperature will decrease. So the temperature falls with distance from the sun. So because the way heat travels in space is through radiation, and the radiation has to cover a bigger and bigger surface area if it has to reach a bigger distance. So the surface area of a sphere over which the radiation which has been emitted by the sun has to spread out is given by the formula 4 pi r square. So as r increases, the energy is spread out as r square. So the amount of energy which reaches will reduce as 1 by r square. So that's why the temperature falls with increasing distance. So Pluto is very cold and Mercury is very hot. Okay. Then what else? Then you have the components of the solar system. So they are divided into three parts. The inner planets, after which you have an asteroid belt. That means you have a region filled with asteroids. So this could be due to a failed planet. So a planet could have formed, but it could not form. So it is still a remnant of the accretion disk filled with stones and dust and other matter. So it's a failed planet, or it could be a planet which burst or exploded or whatever. We can't be sure. So it's filled with rocks which are around 1,000 kilometers big or 1 kilometer big. It varies in diameter. And after that, after the asteroid belt, you have the gas planets, gas giants as we call them, because they are very huge in size compared to the inner planets, which are mostly made of rocky surface, solid surface. So if you can look at this data, you should be able to infer a lot of facts about the planets in our solar system. So Pluto is called a dwarf planet, and so it's not a regular planet because it is not big enough to have a gravitational field of its own, which can hold objects onto its surface. So that is the definition of a planet. So with that definition, Pluto has been removed, and only we have 8 planets revolving around the Sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So as you can see in the first row, the average distance increases with each planet, and the time for orbit in number of Earth years also increases with distance steadily. And then the diameter at the equator of each planet is maximum for Jupiter, 142,980, followed by Saturn, and least for Mercury. So these are the salient features you should remember. And the mass compared with Earth is also maximum for Jupiter, followed by Saturn, and least for Mercury. Okay. And gravitational field strength will also be obviously maximum for Jupiter, followed by Saturn. Interestingly, Uranus. No, after Jupiter, Neptune has a stronger gravitational field. That's an interesting thing. Followed by Uranus and Saturn. Then the average density, if you see, so this explains why Neptune has more gravitational field, because its density is higher than Uranus or Saturn. And density of Jupiter is also a bit high because the gravitational field would have compressed the gas more densely compared to Saturn or Uranus. And the average surface temperature, as you can see, until Earth it's warm. Average surface temperature is 15 degrees for Earth, but Mars onwards it's sub-zero degrees. Not easy for life to survive. Similarly, Mercury and Venus are too hot, more than 170 or 460 degrees. So again, life cannot survive. And the number of moons is maximum for Saturn and followed by Jupiter and then Uranus. So the gas giants have lots of moons compared to the rocky planets. Earth has one moon and Mars has two moons. Okay, so this is the relative size of the orbits, and the planetary sizes are not to scale, they're just represented by dots. Then, okay, we'll continue the next video from here.